Hello students, in this video we will study the second chapter of NCERT, that is relations and functions. So let us start the chapter with its introduction. Now first thing is Cartesian product of sets. Now what is Cartesian product of sets? Given two non-empty sets P and Q, the Cartesian product P cross Q is the set of all ordered pairs of elements from P and Q. That means P cross Q or Cartesian product of P and Q will be equal to PQ, where P belongs to set P and Q belongs to set Q. Let us take an example. Suppose there is set P which has elements 1, 2 and 3 and set Q has elements 3 and 4. Now P cross Q will be equal to PQ, where P belongs to set P and Q belongs to set Q. That means the first element of the ordered pair will be from set P and the second element will be from the set Q. Now first element of the set P is 1. So with 1 we will take all the elements of set Q, that is 1, 3, 1, 4. Now second element of set P is 2. With 2 we will take the elements of set Q, that is 2, 3, 2, 4. Similarly, the third element of P is 3. So we will write it as 3, 3 and 3, 4. Now if you want to find Q cross P, then the first element of the ordered pair will be from Q and second will be from P. Now first element of set P is 3. So with 3 we will write all the elements of the set P, and that will be 3, 1, 3, 2 and 3, 3. Now second element of set Q is 4. With 4 we will write all the elements of set P. So that will be 4, 1, 4, 2 and 4, 4. Now as we see here, the number of elements in P cross Q will be equal to the number of elements in set P into the number of elements in set Q. Now here the number of elements in set P is 3 and number of elements in set Q is 2. So number of elements in P cross Q will be equal to 6. And here you can count the number of elements, that is 1, 2, 3, 4, 5, 6. Now in exercise 2.1, first question, if x upon 3 plus 1, comma, y minus 2 upon 3 is equal to 5 upon 3, comma, 1 upon 3, then find the value of x and y. Here x upon 3 plus 1, comma, y minus 2 upon 3 is given to us is equal to 5 upon 3, comma, 1 by 3. So on equating both sides, we can say that x upon 3 plus 1 will be equal to 5 upon 3 and y minus 2 upon 3 will be equal to 1 upon 3. Now on solving this, we will get x upon 3 will be equal to 5 upon 3 minus 1, or we can say that will be 2 upon 3, and that will give us x equal to 2. Similarly, y will be equal to 1 upon 3 plus 2 upon 3, and that will be 3 upon 3, and that will be equal to 1. Thus we can say here x equal to 2 and y is equal to 1. Now in question number 2, the set A has 3 elements and set B has the elements 3, 4 and 5. Then find the number of elements in A cross B. Now first of all, set A has 3 elements. That means NA is equal to 3. Here B has also 3 elements, that is NB is equal to 3. Now we have to find the number of elements in A cross B. That means we have to find N A cross B. N A cross B will be equal to NA into NB, and NA is equal to 3, NB is also equal to 3. That means NA cross B will be equal to 9. Now in question number 5th, if set A is equal to minus 1, 1, find A cross A cross A. Now set A is given to us as minus 1, 1. First of all, we will find out A cross A. Now A cross A will be the set having the ordered pairs whose first element is from this first set and second element is from the second set. Now this will be, first element will be minus 1, or first order pair will be minus 1, second order pair will be minus 1, 1, third will be 1, -1, and fourth will be 1, 1. Now A cross A will be equal to set A into set A cross A. Again, set A cross A will have the elements. Its elements will be the ordered pair whose first element is from set A and second element is from set A cross A. So that will be minus 1, -1. Now second element will be minus 1, 1. Third, again with minus 1 we will write 1, -1, and then minus 1, 1, 1. Minus 1, 1, -1, -1, 1, 1. Now for 1, on taking the first element 1 as the element of the ordered pair, we will get 1, -1, -1, then 1, -1, 1, 1, 1, -1, and 1, 1, 1. Now in sixth question, A cross B is given to us. We have to find set A and set B. Now as we know that in A cross B will be the set of ordered pairs with first element from the set A and second element will be set from the set B. So set A will be equal to A and B, or you can say set A will have two elements A and B, and set B will have two elements X and Y. Now in seventh question, set A and set A, B, C and D are given to us. We have to verify that A cross B intersection C is equal to A cross B intersection A cross C, and second, A cross C is subset of B cross D. Now here, first of all, we will find out the value of A cross B intersection C. Now B intersection C, set B and C has no element common in them. So we can say B intersection C is a null set. Now A cross B intersection C will be set A, that was 1, 2 cross null set, and that will be equal to null set. Now A cross B will be set of ordered pair with first element from set A and second element is from set B, that we have written here. Now A cross C will again be a set with ordered pairs, first element from set A and second element is from set B. As we see here in A cross B and A cross C, there is no element in common. So we can say that A cross B cross A intersection A cross C is equal to null set. Now from first and second, A cross B intersection C is equal to A cross B intersection A cross C. Now in second part, we have to prove that A cross C is a subset of B cross D. So first of all, we will find out the value of A cross C and then the value of B cross D. As we see here, all the elements of A cross B A cross C, that is 1, 5, 1, 6, 2, 5 and 2, 6 are present in B cross D. So we can say that A cross C is subset of B cross D. In question number 8, now set A has two elements 1, 2 and set B has two elements 3, 4. Now we have to first of all write A cross B, and then we have to find that how many subsets will A cross B have. Here set A is given to us, that is 1, 2 and set B is 3, 4. So A cross B will be the set of ordered pairs whose first element will be from set A and second element will be from set B, and here n cross B has 4 elements. Now we have to find out the number of subsets of A cross B. Now number of subsets of any set is equal to 2 raised to power n, where n is the number of elements of this set. Now here number of elements in A cross B is 4, so number of subsets of A cross B will be equal to 2 raised to power 4, and that will be equal to 16. Now in question number 9, A and B be two sets such that NA equal to 3 and NB equal to 2. If x1, y2 and z1 are in A cross B, find A and B. Now as we see here, A has 3 elements and A cross B will be the set of ordered pair with first elements from set A and second from set B. So first element, that is x, y and z, will be the elements of set A. The set A will be the set having elements x, y and z. Now here set B has 2 elements, so the set B will have the elements 1 and 2, and after that we can find A cross B. Now in question number 9, the Cartesian product A cross A has 9 elements, among which are found -1, 0 and 0, 1. Find the set A and the remaining elements of A cross A. Here n cross A has 9 elements, that means n A cross A equal to 9. Now as we know, number of elements in A cross A will be equal to number of elements in A into number of elements in A. That means NA into NA will be equal to 9, and that will give us NA equal to 3. Now given elements of set A are -1, 0 and 0, 1. Now given elements of set A cross A. Now 2 elements of A cross A are given to us. That means here the first element of the ordered pair will be from set A, and second element of the ordered pair is also from set A. So we can say this set, both the elements of this ordered pair are from set A. That means set A will have elements -1, 0 and 1. And NA was 3, and here we have got 3 elements in set A. Now after that we can find out set A cross A. Now the second topic of the chapter is relation. Now what is relation? A relation are from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. The subset is derived by describing a relationship between the first element and the second element of the ordered pairs in A cross B. Now let us understand this with the help of an example. Suppose there is set A having 3 elements 1, 2 and 3, and set B has 2 elements 3 and 4. Now A cross B will be set of ordered pairs whose first element is from set A and second element is from the set B. Now if we take a relation R xy such that mod x minus y is equal to 1, where x belongs to A and y belongs to set B, then R will have only 2 elements, that is 2, 3, 2 minus mod 2 minus 3 will be equal to 1, and mod 3 minus 4 will be equal to 1. So this R will have only two elements, that is 2, 3 and 3, 4. Now if you see here, the elements of R are present in A cross B. That means this R is subset of A cross B. Now, second thing is, the second element of the relation is called the image of the first element of the relation. That means here 3 is image of 2 and 4 is image of 3. Now, domain of a relation. A set of all first elements in a relation R from a set A to a set B is called the domain of the relation R. Range and codomain. The set of all second elements in a relation R from a set A to a set B is called the range of the relation R. The whole set B is called the codomain of the relation R. In relation R, we have two elements 2, 3 and 3, 4. Now domain of the relation R will be the set of first element of the ordered pair, and here first element of the ordered pair is 2 and 3. So the domain of R will be 2 and 3. Now second was range of R. Now range of R will be the set of second elements in the ordered pair. Now here in relation R, the second element of the ordered pair is 3 and 4. So range will be 3 and 4. The set of elements 3 and 4. Now codomain. Codomain is the set from where we have obtained the range of the relation. Now here range of the relation is 3 and 4, and this 3, 4 we have obtained from the set B. Therefore codomain of the relation R will be the set B, a whole set B. You can also write that this will be equal to 3 and 4, as set B has two elements 3 and 4. That means, as we know, the ranges, we can say the codomain is the set, is the whole set from where we have take range of the relation. Therefore we can say that range of relation or range is a subset of codomain. Now in first question of exercise 2.2, set A is given to us. We have to define a relation R from A to A by R equal to xy such that 3x minus y equal to 0, where x and y belongs to set A. Write down the domain, codomain and the range. Now here set A is given to us and relation R is xy such that 3x minus y equal to 0, where x and y both belongs to A. Now the elements of the range. Now here if we take 3x, now the relation is 3x minus y equal to 0. That means y should be equal to 3x. Now here the elements of the range relation will be, now y is equal to 3x or 3x minus y is equal to 0 is our relation. So on taking the first element, that is 1, as the first element of ordered pair of relation, y will be equal to 3 into 1, and that is 3. Now the second element of A was 2. Now from this y will be equal to 6. Third element is 3, and that will give y equal to 9. Fourth element will be 4, and this will give y equal to 12. and 5 will give us y equal to 15. Now, as we see here x and y both belongs to A. We have taken the x value of x from the set A, and then we have obtained the value of y by the relation 3x minus y equal to 0. But here the x and y both should belong to A. That means the first and second element of the ordered pair should be from set A. Whereas this 15 doesn't belong to set A. So this last pair will not be in the relation. So we have the elements of relation as 1, 3, 2, 6, 3, 9 and 4, 12. Now here we have to find out the domain of the relation. Now domain of the relation will be the set of the first elements of the ordered pair, and here the first elements of the ordered pair are 1, 2, 3, 4. 1, 2, 3, 4. Now range. A range is the set of second elements of the ordered pair of a relation, and here the second element of the ordered pair of relation is 3, 6, 9, 12. So range will be 3, 6, 9, 12. Now codomain is the set from where we have taken ranges. Here range is y and y belongs to set A. That means we have taken all the ranges from set A. So codomain will be the set A. In question number 2, define a relation R on a set N, that is set of natural numbers, by R equal to xy, where y equal to such that y is equal to x plus 5 and x is a natural number less than 4. Here x and y both belong to natural number. Now depict the relation using roster form. Write down the domain and the range. Here R is equal to xy such that y equal to x plus 5 and x is natural number less than 4. That means x is the element of domain of the relation and that is natural number less than 4. So first element of the ordered pair will be the natural numbers less than 4. And 1, 2, 3 will be the elements of domain of the relation. Now here the relation is given as that y is equal to x plus 5. That means if x equal to 1, then y will be 1 plus 5. That will be 6. X in second order pair, x is 2. So y will be 2 plus 5, that is 7. And third element will be 3. And 3 plus 5 will be 8. Now we have to find the domain and range of the relation. The domain will be the set of first elements of the ordered pair, and these are 1, 2 and 3, and range will be the set of second elements of the ordered pair, and that is 6, 7, 8. If we have to find the codomain, then codomain will be the set of natural number as y belongs to natural numbers. In question number 3, set A and B are given to us. We have to define a relation from set A to set B by R equal to xy. The difference between x and y is odd, and x belongs to set A and y belongs to set B. Write R in roster form. We have to write this relation R in roster form. Now here the first element, that is x, is from set A. So if you take first element of A, that is 1, then here he is saying the difference between x and y should be odd and y should be from set B. Now 4 minus 1 will be odd, that means 1, 4 will be the element of the relation. 6 minus 1 is also odd, that will be also the element of the relation. 9 minus 1 will be 8, and that is even number. So 9 minus 1 will not be a 1. 9 will not be the element of the relation. Now with 2. Now 2 minus 4, 4 minus 2 will be equal to 2, and that is even. 6 minus 2 is also even. 9 minus 2 is 7, and that is an odd number. Similarly, we can find the other elements of R. 3, 4, 3, 6, then with 5, 4, and 5, 6. So these are the elements of the relation, where each first element of the ordered pair is from set A and second element is from set B, and also the difference between these elements of the ordered pair is odd. Now in question number 4, in figure 2.7, it shows a relationship between the set P and Q. Write the set in set builder form and in roster form. What is its domain and a range? Now here a relation between set P and Q is given to us, and we have to find this relation in set builder. Here we have to write this relation in set builder form. Now in set, as we see here, now 5 minus 2 is equal to 3. 6, this was 4. Now 6 minus 2 is equal to 4, and 7 minus 2 is equal to 5. That means in set builder form we can write the relation as xy, where this y is equal to x minus 2, y is equal to x minus 2 for x equal to, the value of x is 5, 6 and 7. Or we can also take, if we are taking set P and Q separately, we can also take it as xy, where x minus y, as we see here, 5 minus 3 is 2, 6 minus 4 is 2, and 7 minus 5 will be equal to 2. X minus y equal to 2, where x belongs to set P and y belongs to set Q. And set P and Q are, set P is 5, 6, 7 and set Q is 3, 4, 5. Now in second part we have to write it in roster form. Now set in roster form will be, or this relation in roster form will be R equal to, now first element will be 5, 3. Your first order pair will be 5, 3, second will be 6, 4, and last will be 7, 5. Now third one is domain of the relation. Now domain of the relation is the first element of the ordered pair, and that is 5, 6, 7, and range of the relation will be the second element of the ordered pair, and these are 3, 4, 5. Now in question number 8, set A and B are given to us. We have to find out the number of relations from A to B. Now from here, A cross B will be equal to x1, x2, y1 and y2, z1 and z2. Now since here number of elements in A cross B is equal to 4. So number of subsets of A cross B. Now here 1, 2, 3, 4, 5, 6. Number of elements in A cross B was 6. So number of subsets of A cross B will be equal to 2 raised to power 6, and that will be equal to 64. Now therefore we can say that number of relations from A to B will be equal to 64. So from here we can say that the number of relations from A to B will be equal to the number of subsets of A cross B. Now in ninth question, let R be a relation on Z, that is integer, defined by R equal to AP, where A and B belongs to integers and A minus B is an integer. Find the domain and range of R. Now, as A and B both belongs to integer, and if an integer minus integer is always an integer, whatever integer we take in place of A and B, A minus B will always be an integer. Therefore, we can say that in place of A we can take any integer, and in place of B also we can take any integer number. Thus we can say that the domain of R will be an integer and range of R will also be a integer. Thank you.